Start working with exponential and logarithmic functions and relations. And we're going to start off here by graphing exponential functions. And now here in example 1, which is actually on page 451 in the current textbook, it's asking us to, and it's telling us we're going to graph an exponential growth function. And in a few minutes, we're going to graph this where y equals 4 raised to the power of x. That's what makes this an exponential function. The variable is the exponent. It's in the exponent. In the power, we're raising a base to. And in this case, the base is 4. So that's my base, 4. My variable's in the exponent. Then we're going to state the domain and range. Before we go to the calculator to do that, let's just kind of get an idea of what happens with an exponential growth function and see if this kind of makes sense. So let's say we'll just draw a crude coordinate plane. And with an exponential growth function, it's going to come along really, and I can't draw a straight line in this position. Let me see if I can do a little shift here. It's going to come along the y-axis, and then boom, it's going to have an intercept up here, and then it's just going to take off. Now, let's see why that maybe makes sense. If we're thinking about this, and this would be in a parent function form where we've got f of x equal to a base, in this case it's 4, raised to the power of x, and our base is greater than 1, because 4 is obviously greater than 1. Now, if x is negative at this point, let's just say that this was, as an example, we got 4 raised to the power of negative, I'm going to just say negative 1. This negative right here actually puts that base down in the denominator. So when x is negative 1, we've got 1/4. But what about if we've got 4 raised to the power of negative 2? Well, that's the base goes down here in the denominator, but then 4 squared is 16. Well, 1/16 is smaller than 1/4. How about 4 raised to the power of negative 3? Well, we got 4 in the base. Now it's 4 cubed, and 4 cubed is 64. And we can see that that number, as we're going out towards, as we're moving this way, let's say, on our graph, x is getting smaller and smaller. It's negative. I mean, it's getting more and more negative. My solution then is getting closer and closer to 0. Now, what about when x is 0? We got 4 raised to the power of 0. Well, we should know that anything raised to the power of 0 just equals 1. Doesn't matter what it is. And that's why we would have a y-intercept right there at 1. So when x is 0, 4 raised to the power of 0 is 1. And now we start getting into positive exponents. Well, 4 to the first power equals 4. 4 squared is 16. 4 cubed is 64, and you can see we're headed off to infinity pretty rapidly. What about our domain? Well, our domain is all real numbers. There's nothing that restricts our domain in this base raised to any power of x. But what about our range? You can see that we're all on the positive side of the y-axis. All of our solutions are on the positive side of our y-axis, and so we could say that the range goes from 0, but it never equals 0. It just keeps getting infinitely closer and closer to 0 out to infinity. Or if we wrote that in set builder notation, we might say that y such that y is greater than 1. Excuse me, greater than 0, but it never equals 0. Okay, well, let's go graph the function and we'll take a look at it. All right, well, we're over here on the calculator, and it just so happens that my window screen is open. And you know what? It's always a good idea when you start to work on something new and maybe you don't remember what you did the previous time you were, previous day, or you were on your calculator, is to check your window settings to make sure that it seems like it's going to be compatible with what you're getting ready to do. And we're getting ready to graph y equals 4 raised to the power of x. And so my x minimum at negative 10 and x max at 10 and y minimum negative 10, y max at 10, that seems okay. I think that should be okay for what I'm doing. And another good idea is to check, see if my stat plot is on. Sometimes I may have done a stat plot. So let's go second y equal, take me to stat plot, and sure enough, I see that my stat plot is on, and for what I'm getting ready to do, I want to get that off. So I'm going to click that, go to off. All right, we've turned that off, and now I just want to go to y equal, and looks like I was graphing some piecewise functions there. All right. Well, it won't do that. All right. So let's graph 4 raised to the power of x. So I'll go 4 caret x, and let's go take a look at our graph. And sure enough, just what we said in that previous slide, you can see it almost looks like it's right on the x-axis, but it's because it's just so close. It's not actually ever equaling 0. And we're coming from, as we're moving from the left, and then right here at this y-intercept, when x is equal to 0, y is equal to 1. And again, we said that. So any base raised to the power of 0 is just going to equal 1. Doesn't matter what that base is. And then it takes off. When y is equal to 1, x is equal to 1, y is equal to 4 up here. And then it goes to 16, and we're already off the graph as far as our viewing window. But before we leave, let's go take a quick look at the table. So I'm going to hit second table, see what I got. Okay. And we can see that, so let's start here where when x is equal to negative 4, y is equal to 0.0039. That's 4 decimal places. So that means that's 39 10,000ths. That's a pretty small number in and of itself. But by the time x is equal to negative 1, it is 0.25 or 1/4. Remember, that negative exponent throws that base down in the denominator, so that makes sense. And when x is equal to 0, well, there we go at 1, and then we can see when x is equal to 1, y is 4. When x is equal to 2, we got 4 squared, 16. When x is equal to 3, we got 4 cubed, which is 64. And just out of curiosity, what is x to the 4th power? I think it's going to be 256. Let's see, when x is 4, yeah, 256. And by the time we get to the 5th power, we're at 1024. You can see it's taking off pretty rapidly. Our domain, well, there is no restriction to our domain. It's negative infinity to infinity, or all real numbers. And then our range, again, as we stated earlier, is y is going to be greater than 0 out to forever, for infinity.